Hi all, this is Dr. K. Utra, Assistant Professor, Mathematics in Science and Humanity. This is the regulation of 2025, the subject name Statistics for Management. In this subject, we're going to see correlation and regression. Correlation. Correlation analysis attempts to determine the degree of relationship between variables. Change in one value is reflect on the other. Two variables may be positive correlation, negative correlation, or no correlation between them. Scatter diagram represented of the relationship between the variables. Multiple correlations studying the degree of relationship of more than two variables. For quantitative measurement of the degree of relationship between two variables, Carroll-Person formula is used. We calculate the correlation coefficient or using the formula, or means in this place we using the rank correlation. Correlation quantity has strong and in which director two variables are related. It is being measured using the correlation coefficient which goes that the extent of negative one and positive one. Positive correlation means in this case if the value of one of them goes up, then the value of other one also goes up. That is it going increasing only. Negative correlation, that is when one variable is high, the other is low, and vice versa. It is different, increase and decrease. It is the in the image of correlation. No correlation, no statistically significantly correlated partner, financial wealth, and life satisfaction. In this picture, we are going to see the positive correlation, negative correlation, no regression. Positive correlation. The point lies close to the straight line, which has a positive gradient. This shows that one variable increasing, the other one is increasing. The negative correlation. The point lies close to the straight line, which has a negative gradient. This shows that one variable increase, the other one is decrease. No correlation. There is no pattern to the points. This shows that there is no connection between the two variables. Correlation analysis formula. It is the important formulas of the correlation. When the deviation are measured from the mean value, R is equal to summation of xy divided by square root of summation of x square summation of y square. Second, if no assumption average is taken for x and y series, R is equal to n of summation of xy minus summation x summation y divided by square root of n of x square minus summation of x the whole square into square root of n of summation y square minus summation y the whole square. If the deviation of x and y series are taken from assume the value R is equal to square n of summation of d of x d of y minus summation of d of x summation of d of y divided by square root of n of summation of d of x the square minus summation of dx the whole square into summation of n of summation of x dy minus summation of dy the whole square. In the bivariate frequency distribution, R is equal to n into summation of dx dy minus summation of dx summation of dy divided by square root of n of summation of f of x square minus summation of f of dx the whole square into square root of n of summation of f into d of y square minus summation of f into d of y square the whole square. In this place, f is using the function of x and y. And frequency of distribution. Properties. The value of R always lies between -1 and +1. The correlation coefficient is unaffected by the change of origin of reference and the scale of reference. Then we are going to see some problems. Find Carroll-Person coefficient of correlation from the wage and cost of living. In this place, we are going to the 10 type of wages. It is mean means that 10 values 100, 101. In this value we calculating the total value and divided by the number of age. That is we going to know summation of x is equal to 990 divided by 10. We getting the mean is equal to 99. Then x square we doing cost of living on the spot we going to see the mean. It is 970. Total of wage of cost of living is 950 divided by 10. This mean is known as 95. Y is equal to y minus 95 and y square we going to see. Then x and y. In this correlation, we going to the rank correlation. R is equal to summation of xy divided by square root of summation of x square summation of y square. My equal to 61. Summation of xy is equal to 61 divided by square root of 54 into 96. We getting the answer 61 by 72. R is equal to 0.847. There is a high degree of relationship between the variable wages and cost of living stated in the problem. In this picture, we going to know the no correlation or positive correlation or no negative correlation. In this figure, we getting the only negative correlation only we getting in this problem. Second, the following are the rank obtained by the 10 students in statistics and management mathematical subject. To the extent in the knowing of the student in the two subject are related. Statistics is 10, mathematics also the difference of x and y, and d is equal to d square. We getting the total of summation of d square is equal to 36. In this formula we getting p is equal to 1 minus 6 of summation of d square by n into n square minus 1. On substituting the values, p of is equal to 1 minus 6 into 36 divided by 10 into 100 and minus 1. We getting the answer p is equal to 0.7818. Then in this picture we going to the getting the correlation diagram. It is a positive correlation is the blue color is showing the positive correlation. Other than is showing is a negative correlation. Then we going to take the topic of regression analysis. Regression is the measurement of the average relationship between two or more variable in terms of the original unit of data. If y is depending variable and x is the independent variables, the linear relationship between the variable is the regression equation of y on x. Therefore, we getting the y is equal to a plus b of x. The parameter of the equation are determined using the principle of least square method. The estimation of regression line least square method. In this we getting depending of x and y. The regression of equation of y x on y is x is equal to a plus by, where x is dependent variable, y is independent variable. The regression equation of y on x is y is equal to a plus bx, where y is depending variable, x is independent variable, and the values of a and b in the above equation are found by the method of least of square reference. The value of a and b are found with the help of normal equation given below. Summation of x is equal to n of a plus b summation of y. Summation of xy is equal to a of summation y plus b of summation y square. Second, summation of y is equal to n of a plus b of summation of x. Summation of xy is equal to a summation of x plus b of summation of x square. Deviation from the arithmetic mean method. The calculation by the least square method or quiet compression from the value of x and y are large. So the work can be simplified by using this method. The formula for the calculating of regression equation by this method. Regression equation of x on y. Therefore, we getting x minus x bar equal to p of xy into y minus y bar. Regression equation of y on x equal to y minus y bar equal to b y of x equal to into x minus x bar. Then we going to show Estimation of regression line. Regression coefficient of p of x comma y and p of y comma x. B of x comma y is equal to summation of xy minus summation of y square. B of yx is equal to summation of yx divided by summation of x square. Properties of regression coefficient. R is equal to plus or minus square root of b of xy, b of yx. Value of R is positive if the both the coefficient are positive and vice versa. It will be different, positive or different. One of the regression coefficient is greater than 1 while the other is less than 1. Therefore, we getting b of yx less than or equal to 1 by b of xy. Example, from the given data obtaining the regression equation by taking deviation from the actual mean of x and y. X and y, we getting the variables. X is equal to x minus x, y is equal to y minus y, x square, y square, then we getting xy. After that, we value the summation of x is equal to 24, summation of y is equal to 29, summation of x is equal to 0, summation of y is equal to 0, summation of x square is equal to 26.8, summation of y square is equal to 38.8, summation of xy is equal to 28.8. Regression equation of y on x is equal to x minus x bar equal to b of xy into y minus y bar. B of xy is equal to summation of xy by summation of y square. All this value we getting the putting the values in the formula, we get the x statement. X is equal to 0.74y plus 0.4. The regression equation of y on x is y minus y bar equal to b of yx x minus x bar. B of yx is equal to summation of yx divided by summation of x square. In this, we getting the value from the sum. We put the values in this formulas. Then we get y is equal to 1.07x plus 0.66. Next, difference between the correlation and regression. Basic for the compression. Meaning correlation is the statistical meaning which determines relationship or associate of two variable. Regression describes how an independent variable is numerically related to the dependent variable. Usage to represent linear relationship between two variables. Regression to fit the test line and estimate one variable on the basis of another variable. Depending and independent variable. In correlation, no difference. Regression, both variables are different. Identification. Correlation coefficient indicates the extent to which two variables move together. Regression indicates the impact of a unique changes known variable x on the estimate variable y. Objective to find a numerical value expressing the relation between variable, to estimate value of random variable on basis of the value of fixed variable. Then we going to see the real life application of correlation analysis. First one, understanding financial marketing, medical research, quality control and predictive modeling. Then real world application of regression analysis. First one, economic forecasting. Second, healthcare and medical research. Third, marketing and customer behavior. Fourth, environment science. Fifth, quality control and manufacturing. Sixth, education and academic research. Seventh, sports analysis. Eighth, risk management and insurance. Thank you.